So today we're going to start chapter 23. We're going to talk about probability distributions, and we'll start with discrete, and then we're going to move on to continuous. So discrete. Today we're going to talk about something called random variables. Random variables. And so, but let's see. What this unit, what we're going to be doing is we're going to be incorporating everything we learned about functions and putting it on probability and statistics. It's kind of interesting. So, a random variable is an outcome, is a set of outcomes that corresponds to a probability. So let's assume that, take a step back, let's assume that, let's see, you're a statistician, you're asking questions, and the question is, how many times a week do you ride the bus? So number of times a week you ride the bus. And it may seem, you look at the data it's telling you, and you think, okay, fine, 100 people were asked, and here's the outcomes. We'll call it X, for the variable. So and the answers are there's 1, 2, 3, 4, and we're told that, what did I write here? 10 people said, it seemed that 10 people rode the bus one time, and it seemed like from the data that 25 people rode the bus 2 times. There was 48. For the last time, let's say it's a math question, how many people rode the bus 4 times, and you say, fine, 35, let's see, 35 and 48 is 83, and so there's 17 left over. And so you're like, fine, that's no big deal. But this is not the data. I've misread something wrong. That's not what we're going to be dealing with. Instead of specific outcomes, you're going to be given percentages. And so I don't really know. You can think of it that way, but you really don't know there's 100 people anymore. You don't know. But what you do know is that based on experimental probability, 10% of the respondents said they rode the bus once a week. 25% said they rode twice a week. 48% said they rode 3 times a week, and 17% said they rode 4 times a week. So the idea is now, these are now probabilities. So for example, I asked a random person in the city, hey, how many times did you ride the bus last week? There's a 48% chance that they're going to tell me 3 times a week. So in this unit, we have outcomes, but they're not attributed to tallies anymore. We may not know, but they're going to be connected to probabilities, and that's the idea of a random variable. Now, in this, it's discrete and continuous. So in the first unit, there's specific outcomes. 1, 2, 3, these are the random variables, and they connect or map to a probability. So we would say the probability that the random variable is equal to 1 is equal to 10%. And that's the notation, that's the idea, that's what's going on here. So once again, we use a capital letter. So big X is the potential outcomes, the number of times you ride a bus. Usually in math, we've been doing usually it's like all reals or all integers. No. Here, in the probability unit of random variables, for the discrete, there might be just a fixed number. 1, 2, 3, 4, that's it. And all of these connect to map to, this is like a function to a probability. And once again, you can clearly see this equals 100%. So all the probability connects. This is known as the probability density function. And yeah, function is the same function. Everything goes to, so 1 goes to 10%, 2 goes to 25%, and so on. So all these ideas are coming back. So what is the probability density function? So I might say, what is the PDF of rolling a die? So first thing, X is the outcome, which is 1, or the face up on a die, right? And so the outcomes are, here's X, 1, 2, 3, 4, 5, 6, and we know the probability that X equals a specific X. Well, what's the answer? Well, you know this. So 1 is a sixth, a sixth, a sixth, a sixth, a sixth. This is actually known as a uniform distribution. Uniform distribution. Now there's some problems in the book, but the idea is you're figuring out what are the possible outcomes. This is also like the sample space. And the idea is you're connecting it to a probability. Here's a question out of the book. So they give you this like square, and they break it up like this. Let's see, what do they do here? And they call this region 1, 2, 3, 4. And the question let's see, this is 0.7. This is 1.2, this is 1.0, and this is 1.2. And they say the probability of, whether it's like throwing a dart or some type of ball, the probability of hitting a region is proportional to its area. So we can write a statement. The probability is proportional to the area. So we can start to make a table of values, right? We can start, so the probability that X equals 1 is equal to, well, the area of 1 is 0.7, but it's proportional. The probability of 2 is same thing. Let's see, 1.2 times 1, this is 1.2, but it's K. The probability of 3, is, let's see, 1.44, and the probability of 4 is equal to, 0.84 K. So the idea here is, once again, the idea here in this unit is we're creating a function. We're connecting outcomes to probabilities. Well, this just becomes an algebra problem. This is a nice, question 1 on AB. Question 1, they like the stuff. Let me move my computer over. How are we going to figure this out? It's very straightforward. Very straightforward. You'll notice if you look at all the exams, this is like question 1. The sum is, add these up, 0.74 plus 1K, 1.2K, plus 1.44K, plus 0.84K. This equals 1 because the sum of the probabilities equals 1. Add together, what do we got? We get K equals 0.239. Good. And that's basically it. So, I could say, what's the probability that X equals 1? What's the probability that X equals 1? You would say, fine, it's 0.7 times 0.239. Hey Siri. 0.7 times 0.239.
0.7 times 0.239 is 0.1673.
So the probability that x equals 1. Let me ask you something. What is the probability that x is greater than or equal to 3? Well, you look at this, you go, okay, what's greater than or equal to 3? It's the probability that x equals 3 or the probability that x equals 4. What if I ask you, what is the probability that x is greater than or equal to 2? Well, you might say, okay, Mr. Riley, it's the same thing. The probability of x equals 2, or the probability of x equals 3, or the probability of x equals 4. But you know what? This is a lot of work. We're mathematicians. We're lazy, right? So anything comes faster, and you say, you know what? This is also equal to 1 minus the probability that x equals 1. So this is your faster way of doing that. And that's basically, so these are things we will be practicing, this idea of these probabilities. Last thing, what is the mode? What is the mode? Because, we had a distribution. The question is, what is the mode? Well, the mode in this case, it's the outcome with the highest probability. And I need you to, this is a perceptual shift. This is a change because we no longer know exactly how many people. We're now depending on the probabilities of an event. And so, yeah, in my original example, I did interview 100 people, but you're not going to be given the amount of people. You're going to be given probabilities. So the mode is the outcome with the highest probability. And that's basically it. We're good.